Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at a library of advanced string parsing functions. In this series of videos, I'll be covering the creation and use of libraries. So you might ask, why use libraries? Why not just write code whenever you need it? Well, if you're writing a lot of applications, having common libraries that contain functionality that you use often will save you time, both coding and testing. It will also make your code more readable and therefore maintainable, which is always a good thing. The basic language, and PowerBasic in particular, have some very powerful string manipulation functions. Today we're going to look at a library for advanced parsing of strings. While we're using the console compiler today, these string functions can quite as easily be used within the Windows compiler. So we're going to add a pbcommon strings.include file. This is one we've used before and we're going to enhance it today. In addition, we're going to be using the file handling routines to read a file into an array. So we're declaring a local variable, strFilename, an array, strwork, and I've also added a local variable called strheaders. We'll come to that in a moment. So the read the file into an array function exists within the file handling routines library. This takes two parameters, the first being the name of the file you wish to load, and the second parameter is a pointer to the array into which you want to load the information. So our first thing to do is to pick up the headers from the file. But before we do that, let's have a look at the file itself. This is the file we're going to be looking at. It has a header line comprising of the names of the columns and a number of records containing the data. So when this file is loaded into our array, the first line on the screen here, the header line, is loaded into the 0 element of that array. And the subsequent lines are loaded into subsequent elements. So having loaded the array, we will load that 0 element into our string variable, strheaders, and then we will display that on the log. So if we run that now, we can quite happily see that the first row of the file, the headers, are appearing on our log, so they have been successfully loaded into our array. One of the dilemmas with handling files provided from an external source is that you cannot always guarantee that the next version of the file you receive will be in exactly the same format. You may well develop your code to assume that the first name is always in the very first column, and the account number is always in the very last column. However, over time, the file format of this file may well change, and you will have to revisit your code to do a bit of recoding. For example, if they inserted a new column between the address column and the telephone number column, then any reference you had to the fourth column would have to be amended. So hard coding your application to pick values up by column numbers is fraught with the problem that if the file format changes, so will your code. You can of course get around this by using constants for the column numbers. And then, since your constants are all defined at the beginning of your application, merely changing the constant from a 1 to a 2 will mean you're picking up from a different column. However, this still means that you'll have to change your application when the file format actually changes. So what we're going to look at is a way of working out where the columns actually exist, by name. So we will first declare a number of local variables, all as longs, so they can store the column position number for the first name, surname, address, telephone, and account number. The next thing we wish to do is to work out, for example, the first name column, which column number is it actually existing in. To allow us to do this, we're going to use one of the new functions in our new library. If we have a look at the index at the beginning of our new library, we will see there are a number of functions actually named. The one we're going to use first of all is the Parse Find function. The Parse Find function takes a number of parameters. It takes the string that you wish to interrogate, it takes a delimiter, it takes the search criteria. So how can we use this within our application? Well, as we know the column header name is first name, we know the string holding all the headers is stored in str headers, we know that the entire file is comma delimited. If we call our Parse Find function with this information, it will return the column in which the first name actually exists. And then having got that column number, we can display that on our log. So we can see the column header is appearing here at the top, and the first name column is column number 1. We can repeat this for each of the other columns within the file, picking up the column position for each one. So having worked out the column position, we can then use the parse command on its own to work out the value sitting in that particular column. And over time, if the file format does change, for example inserting a new column between the surname and the address, then our code will still work without any change whatsoever. In fact, the order of the columns becomes irrelevant as far as the application is concerned, as long as the column name does not change. The Parse Find function is a case-dependent search function. Should the name of the column change in any way whatsoever, including the casing, then it will fail to find the column. This can be quite usefully used to determine whether all the columns in a file are actually needed for your application. There may well be columns in the file which your application has no need to read. So whether they are there or not, or what position they're in, from the application's point of view, is not important. As long as all the columns that you're looking for exist and can be found, then the application will work. So we can display each of these column numbers on our log. Telephone number is indeed column number 4. So if we want to use the parse command to pull that information out of our array, how would we do it? Well, since the information is in an array, and we can use a for next loop from 1 to the upper bounding of the array, we can display the record number and the telephone value by using the straightforward parse command, giving it the element of the array. In this case we're saying it's got no delimiter. Now the parse command has a very special function for comma delimited files. If you have a comma delimited file which may well have embedded commas in, for example, an address, you would expect that column to be wrapped in double quotes. If you use the parse command with a zero-length string delimiter, the parse command will automatically work that out for you. And we're telling it the value of the telephone variable, which in this case is the column in which the telephone data is actually stored. So if we run that now, we will see it pulls out the telephone number quite successfully. So since we have this data sitting inside a single dimensioned array, all columns are held in one element of the array. If we need to update, for example, the telephone number for a record, how would we do that? In the file, the telephone number is the 4th column. Now, as each of these records is stored in its entirety in one element of the array, there is of course information before the telephone number and information after the telephone number. And all we want to update is the telephone number itself. So there is also a parse put function within a new library which can be quite happily used to slot your updated information into that column. So if we set into a variable the value that we wish to slot into that element of the array, and we want to update record number 1, we can use the parse put function to store that information back into the array. The parse put function returns a string, which is our updated string. At the moment, the element in the array would contain the entire row, as you can see here. And we're passing it the element of the array, which is the entire string. We're passing it a delimiter of a comma. We're passing it the column that we wish to update, and we're passing it the value we want to put into that column. And the function will return the entire updated string, which we're then updating the array with that value. So to see if that has successfully worked, let's try printing that out to the log, printing out the record number, the telephone, and what it's actually equal to. So if we run that now, we can see the original value of record 1 had 7,000 as the last 4 digits of the telephone number. However, after the update, record 1 now has 7,010. So after having updated the element in the array, if we output it again to our log, we can see that the value has now been updated from 7,000 as the last 4 digits of the phone number to 7,010. So if we have a look at the common strings library, we will see each of the functions that's actually contained within it. There is our Parse Find function, which takes in our 3 parameters. It uses the parse command within it, of course, within a for next loop for each of the columns. And if it does find a match, it will return the column number. Parse put takes 4 parameters. One of those parameters is the delimiter, and our delimiter is specially handled for those delimiters for comma-separated variable files to make use of the special functionality of the parse command. It then calls 2 work functions, a start range parse and an end range parse. The start range parse is all the data before the element we wish to insert, and the end range parse is all the data after that. It then quite simply adds the before to our value and then the after variable, ending up with an updated string, which it returns as the return from the function. So these few extra advanced parsing commands allow you to store values in delimited strings. For example, if we have a formatted string with 4 zeros which is delimited by the pipe character, we can quite happily update any one of them, simply by using the parse put command. We can slot into element number 3 the value 44, and into element number 4 the word rabbit. As we can see, our string started off with 4 zeros delimited by pipes, the third value changed to 44, and the fourth value to the word rabbit. So having these common library functions should make life a little easier when you're handling long strings, and is especially useful for reading files. But that's it for today. Thank you for watching.